Good morning, students. In the last period, discussed about the lowering of vapor pressure. That is the one of the colligative property. Today, we will see about another colligative property, that is boiling point elevation. Before knowing about the boiling point elevation, we must know what's meant by the boiling point. As we know that, suppose this is the container and in this the water molecule. Water is placed into this, and we are supplying the heat to this container. When we are giving the heat to this liquid or water, at that time the vapors are coming in the upward direction. At a certain temperature at which this water boils, that is the boiling point of the water. Generally आपण त्याला त्या पाण्याचा boiling point असं म्हणतो. म्हणजे as you know that 100 degrees Celsius is the boiling point of the water. In other words, the boiling point of a liquid is nothing but a certain temperature at which the vapor pressure of a liquid becomes equal to the atmospheric pressure. This is the atmospheric pressure. When you are giving the heat to this liquid, at that time the vapors are coming in the upward direction, and these vapors create a pressure on the surface of this liquid. At a certain time, the pressure is applied by the atmosphere. At a certain temperature at which both the atmospheric pressure and the vapor pressure is equal, that temperature is called as the boiling point of that. Now we have to discuss about the boiling point elevation. The boiling point of a liquid is the temperature at which the vapor pressure equals the applied pressure. For liquids in the open container, the applied pressure is the atmospheric pressure. It has been found that the boiling point of a solvent is elevated by dissolving the non-volatile solute into it. Thus, the solutions containing the non-volatile solutes boil at temperature higher than the boiling point of a pure solvent. Suppose this is the container. One of the solvent is here, pure solvent. And when we are giving the heat to this, the boiling point of this pure solvent is certain. Suppose that it may be, for example, 90 degrees Celsius. But when a non-volatile solute is added into this, at that time the solution, the boiling point of this solution increases. Boiling point of this solution increases. The boiling point of the pure solvent is less as compared to the boiling point of the solution in which the non-volatile solute is. There is the difference. When non-volatile solute is added into this solution, at that time the temperature, boiling point of this solution increases. For example, 110 degrees Celsius, 110 degrees Celsius. Means there is a large difference between these. Here, the boiling point of the pure solvent is 90 degrees, while the boiling point of the solution in which the non-volatile solute is added is, we are taking the example that is 110 degrees Celsius. And that difference is the elevation of boiling point or the boiling point elevation. Now, दोन्ही मधला जो फरक जो आहे, that difference is called as the elevation of boiling point. If TB0 is the boiling point of the pure solvent, if TB0 is the boiling point of pure solvent, and the TB is the boiling point of the solution in which the non-volatile solute is added. At that time, this TB is greater than the TB, and the change in elevation of boiling point, we can say that the delta TB is equal to TB naught, TB minus TB. This is the elevation of boiling point. याला आपण elevation of boiling point असं म्हणतो. Then when we plot the graph between the pure solvent and the solution, at that time we can say that to understand the elevation of boiling point, let us compare the vapor pressure of the solution and those of pure solvent, and the vapor pressure of the solution of the pure solvent are plotted a function of temperature. At any temperature, the vapor pressure of the solution is lower than that of the pure solvent. Hence, the graph shows that the boiling point delta TB is equal to x2 P1 naught. म्हणजे या ठिकाणी elevation, boiling point elevation and the concentration of the solute यांचं comparison, यांचं रेशो कशा पद्धतीचा आहे हे जर आपण पाहायचं म्हटलं तर आपल्याला लक्षात येईल की बाबा how the boiling point elevation is compared with the concentration. The boiling point elevation is directly proportional to the molality of the solution. That is, the boiling point elevation, that is delta TB, is directly proportional to molality. Delta TB is equal to delta TB is equal to KB, where KB is the proportionality constant, where M is the molality of the solution, and the proportionality constant Kb is called as the boiling point elevation constant or the molar elevation constant. If molality is 1 and delta Kb is equal to Kb, the boiling point elevation constant or ebullioscopic constant is produced by 1 molar solution. ज्यावेळेस आपण समजा जर if we are taken the molality is equal to 1 and the Kb delta TB, that is the boiling point elevation, is equal to kb. Then the azioscopic constant is the boiling point elevation produced by 1 molar solution. 1 molar solution at that time. And the units of this boiling point elevation constant, that is kb, is equal to kg Kelvin kg per mole. Unit of this kb is equal to काय असेल द केल्विन मोलार kg per that is the unit of this boiling point elevation constant. We are dealing with the system whose temperature is not constant, therefore we cannot express the concentration of the solution in molarity, which changes with the temperature, whereas the molarity is the temperature independent. Therefore, the concentration of the solute is expressed in mole per kg rather than the mole per liter. म्हणजे या ठिकाणी boiling point elevation constant is directly proportional to its molarity. मोलॅरिटीच्या प्रमाणामध्ये समप्रमाणामध्ये ते आपल्याला डायरेक्टली प्रोपोर्शनल असलेला आपल्याला. Then the molar mass of the solid from the boiling point elevation, we can take that the molar mass. How we can calculate the molar mass from this? We'll see that. Suppose we prepare a solution from the equation. Last I have seen that is the delta TB is equal to delta TB is equal to, that is kb m. म्हणजेच elevation of boiling point is directly proportional to the molarity. By removing the proportionality constant, we can take the proportionality constant K. Here, suppose we prepare a solution by dissolving W2 grams of solute. Weight of solute W of gram of solute. Weight of solute, that is किती आहे हो W2 gram. Then solution, so solute in the W1 gram of solvent. W1 gram in solvent. Then the moles of the solute in W1 gram of solvent is equal to moles of solute. काय किलो moles of solute, that is the W1 W2 upon M2 is the moles of solute in W1 gram of solvent. W2 upon M2, where M2 is the molar mass of the solute. हा M2 काय आहे? M2 is molar mass of solute. Molar mass of solute काय आहे? M2, and the moles of solute in W1 gram, that is equal to W2 upon M2. Mass of solvent W1 is gram is equal to W1 upon 1000 gram. That is the mass of solvent is equal to mass of solvent काय आहे मास ऑफ सॉल्व्हेंट W1 upon 1000 grams 1000 kg. Here mass of solvent. By expressing the molality, M is equal to molality M. Molality is equal to काय आहे moles of solute divided by the mass of solvent in kg. Mass of solvent in kg. Mass of solvent in kg किती आहे W1 upon 1000 and moles of solute किती आहे W2 upon M2. Then by putting this W2 upon M2 divided by mass of solvent in kg काय आहे W1 upon 1000 that is W1 upon 1000. कारण काय सॉल्व्हेंटचा मास कशामध्ये पाहिजे आपल्याला kg मध्ये पाहिजे that is the mole per kg. Mole per kg. By substituting the values in these W2 आता ही m च्या व्हॅल्यू मध्ये पुट कर डेल्टा टीबी च्या इक्वेशन मध्ये पुट कर सपोज दिस इज द इक्वेशन 1 substitute value of m in equation 1. Equation 1 क्या है डेल्टा TB is equal to KB into m. m क्या है W2 upon m2 divided by W1 upon 1000. Then m1 is equal to काय येईल आता हे जे इक्वेशन जे आहे आपण रिअरेंज केल्यानंतर m2 is equal to by rearranging this equation m2 is equal to 1000 kBW 1000 into kBW divided by m2 W1 delta TB हे आपल्याला मोलार मास या फॉर्म्युल्याच्या सहाय्याने आपल्याला कॅल्क्युलेट म्हणजे मोलार मास फक्त या ठिकाणी एक गोष्ट लक्षात ठेवा दीज आर द डेफिनेशन्स ओनली द बॉइलिंग पॉइंट एलिव्हेशन म्हणजे काय दोन बॉइलिंग पॉइंट मधला डिफरन्स कुठला प्युअर सॉल्व्हेंटचा बॉइलिंग पॉइंट and when the non-molar solute is added into the solution at that time the boiling point will be increased and that difference is called as the boiling point elevation. Boiling point elevation is nothing but delta T and the boiling point elevation is directly proportional to molarity. Then delta T is equal to Kb into m. Kb काय आहे proportionality constant. Suppose that W2 gram of the solute is dissolved in W1 gram of solvent. At that time the number of moles of solute काय आहे W2 upon m, where m2 हे काय आहे molar mass of the solute. Then the mass of the solvent is equal to W1 upon 1000 in kg. Then what's the definition of the molarity? Molarity is equal to it is the ratio of moles of solute to the mass of the solvent in kg. Moles of solute काय आहे moles of solute W2 upon m divided by the mass of solvent in kg that is W1 upon 1000 kg. Then substitute this value into this equation. m ची व्हॅल्यू ही या इक्वेशन मध्ये ठेवून द्या तुम्हाला m2 ची व्हॅल्यू आपल्याला भेटून जाईल. That is the molar mass of the solute from the boiling point equation. Okay, तुम्हाला